Okay, students, this is our first lesson from Chapter 3. Our learning objective is identifying pairs of lines and angles. Most of these words here, you can see that we have several vocabulary words. Most of those words here may look familiar to you as they are review words, but we need to go over them nonetheless so that we can make sure that we're all on the same page. We're going to start here with parallel lines. And parallel lines, as you may recall, are lines in the same plane that do not intersect. Whenever we're drawing a plane, remember we use a parallelogram. So I'm going to draw a parallelogram. And the parallelogram, we just use that to represent our plane. Remember, a plane stretches on in all directions forever. When we name a plane, remember that we use a capital cursive letter. I'm going to use the letter N. So I just put a little curly Q on the top of it. So there's my letter N. So that's plane N. And I have line L and line M are both in plane N, and they are parallel. They do not intersect. And we say that L is parallel to M. The next one that you see here is skew lines. And skew lines, you may recall, are lines that do not intersect, but they're not in the same plane. So here, the best way to represent that is by drawing a box. To draw a box, a three-dimensional figure, a rectangular prism, I'm going to draw a rectangle. Then I'm going to draw this exact same rectangle, but I'm going to shift it up and to the right. And then I'm going to connect the dots, the corners. Okay, so here, if I choose this line right here, I'm going to stretch it out, put arrows on the ends to show you that they actually do go on forever. The blue line here and this red line here, these are skew lines. Notice how the blue line is either in this plane over here or the base, and this red line is either in the front face or it's on the right face, the right side. Okay, so those are not coplanar, they're not in the same plane, and they do not intersect, so those are skew lines. The next one, perpendicular lines. Perpendicular lines are lines that intersect to form right angles. So here, if I have two lines intersecting, and again, these are in the same plane. So here I've got plane M. There's my plane M. And I have two lines intersecting, line 1 and line 2. These are two lines, and they form four right angles. So that right there, these two lines, line 1 and line 2, we say are perpendicular. Line 1 is perpendicular to line 2. Parallel planes are planes that do not intersect. And again, the best way to represent this one is with a box as well. So let's go ahead and draw another box, another rectangular prism, same as we did before. Connecting the corners. The parallel planes would be like the front face and the back face, or the left side and the right side, or the top and the bottom. I'm going to shade in the left side and the right side. Those are parallel planes. Okay, next we have transversal. A transversal is a line that intersects two or more lines. So here, if I draw two lines, just two random lines, here's one, here's another one. If I take a line and I draw it through, and it goes through both of these, then this line right here is T, my transversal. This is line 1, this is line 2, and T is going through both of them. So that's a transversal line. Okay, next we have corresponding angles. Okay, so corresponding angles are two angles which have corresponding positions. To talk about corresponding angles, we're going to need a situation where we have two lines, line 1, some random line, here's another one, line 2. So we have two lines that are cut by a transversal. Corresponding, and I'm going to go ahead and name these angles 1, 2, 3, 4, 5, 6, 7, 8. So corresponding, for example, would be both angles are above the transversal and to the left of each line. So above the transversal would be up here, and to the left of the line would be this angle here and this angle here. So 1 and 3 are corresponding angles. I'm sure you can find a couple more. So here, this is above the line and to the right, so 2 and 4 correspond. 5 and 7 are both below and to the left, and then 6 and 8 are below and to the right. So 2 and 4 are corresponding angles, 5 and 7 are corresponding, and 6 and 8 are corresponding. Alright, the next one is alternate interior angles. Alternate interior angles are two angles which lie between the two lines and on opposite sides of the transversal. Okay, so here I'm going to draw the same similar situation. Line 1, here's line 2. Here's my transversal. So they lie between the two lines. So between the two lines is going to be the shaded area here. Everything inside. Interior. Okay, so this orange area is interior, on the inside. Now the word opposite here means on opposite sides of the transversal. So that means that we are talking about, if we number them again, 1, 2, 3, 4, 5, 6, 7, 8, we are talking about 2 and 7, and we're talking about 3 and 6. So here, we're talking about angle 2 and angle 7, as well as angle 3 and angle 6. Those are alternate interior angles. Alright, the next one. Alternate exterior angles. I'm going to draw the very same pattern here with two lines. Line 1, here's line 2, and they are cut by this transversal. Okay, exterior is going to be in the yellow. Exterior means on the outside, so we're talking about this outside area here. And to make things simpler, I'm going to go ahead and number the angles again. This is angle 1, 2, 3, 4, 5, 6, 7, 8. So exterior angles are going to be the 1, 5, 4, and 8. And we want two angles which lie outside of the two lines and on opposite sides of the transversal. So alternate exterior angles are going to be angle 1 and angle 8, as well as angle 5 and angle 4. Okay, last vocab word today, for this page, is going to be consecutive interior angles. Okay, so here, drawing the same pattern here. two lines, line 1, line 2, cut by a transversal, again we're on the inside, so I'm going to use the orange to show you the inside, because we're the interior. Number them again, 1, 2, 3, 4, 5, 6, 7, 8. So here, consecutive interior means two angles, which are on the inside, but they're on the same side of the transversal. So this one's going to be angle 2 and angle 3, as well as angle 6 and angle 7. Okay, so now let's take a look at this example down here. Looks kind of like a block of cheese. It's a triangular prism. We have planes P, Q, and R. P, Q, and R happen to be the base, this bottom one down here, P, Q, R. That's this plane. And NOM is the top plane. That's this one up here. Alright, so which vocab word could we use to represent the orange and the blue planes? Well, those are going to be not intersecting, so those are going to be parallel planes. Alright, next, segment MO. Segment MO, let's go right here. It's MO, and RQ is going to be this guy right here. Alright, so now if you take a look, ask yourself, are they in the same plane? Yes, they're in this plane over here. Do they intersect? Doesn't appear to intersect, so those would be parallel lines. I know we call them segments, but they fall under the parallel. We can call them parallel segments or parallel lines if we want to match it to our vocabulary word. Okay, next. MN is going to be this guy right here. MN. And again, RQ was in red. Are they in the same plane? This one is on the back side or the top. This one's on the this back side or the bottom. So these are not in the same plane, and they do not intersect. So when they're not in the same plane and they do not intersect, that would be skew lines. Okay, so yes, these are segments, so we call them skew segments, or if we want to keep it the same as our vocabulary, skew lines. All right, next. The next page, we have parallel postulates and the perpendicular postulate. Okay, the parallel postulate says if there is a line and a point not on the line, then there is exactly one line through the point which is parallel to the given line. Alright, so the picture that I'm going to draw for you is, first we have if there's a line, so here is a line. line L, and a point not on the line, so a point just kind of up here floating on top. They're saying that there's only one way that we can draw this line. So if we take a straight edge and we try to draw a line through this point, this would not be, if I drew it like this would not be parallel. So I keep straightening it out until I get parallel, and there's only one way to draw that so that it goes through this point and is parallel. So this is line P, and we say that we say that L is parallel to P. Alright, the next one, perpendicular postulate. So we're going to do the F then again. So F, there is a line, and a point not on the line. Then there is one line through the point which is perpendicular to the given line. Okay, again, here's line L, and this point P that's not on line L. What they're saying is there's only one way. There's a bunch of lines that we can draw through here that will intersect this line, a whole bunch of them, but there's only one line that we can draw that will be perpendicular, form right angles to L. So I'm going to use P again. So we say here, P is perpendicular to L. Okay, next. Alright, so let's practice what we have in part 2. So I'm going to pause right here. This will be part 1, and the next part of the notes is going to be part 2. I want you to try to practice your vocab, and then we'll come back through and check to see if you have it right. So do interior angles, exterior, alternate exterior, corresponding, and consecutive. And try to list all the relationships that you can.